3.2 is all about the graphs of functions. So let's say we have a graph of any old function f of x. Some things that you should know are some notation, and then we'll go through some of those objectives. So for instance, if we have a point corresponding to an x value of c, if I go up and I find this point on the graph, we say the x-coordinate would be whatever that c value is. And then to find the y-coordinate, assuming we have a rule for this, what would I do with the c value? How do you find an output if you know the input? Plug it in. So that means we're going to find whatever f of c is. That is y. That's the y value corresponding to plugging in c. This is why we're going through the notation. Very important that you know the difference. Question?
What's the p represent?
A point. A point p. Okay. In other words, this number on the y-axis will also have or correspond to whatever f of c is, because that represents a y value. Okay, so this is what the notation stands for. Okay, so instead of having it x comma y, since f of x really is y, when we're looking for y when x is c, you just use this notation. This means the y coordinate when c is plugged into the f of x function. Okay? Now, some things that you should be familiar with already are the vertical line test. Anyone tell me what that is? Vertical line test says you're right, if you take a vertical line, and what do you say about 2 points? If this vertical line intersects at 2 points, it's not a function?
Yeah.
How many times should a vertical line always intersect? Once. Very good. So let's say this. Any vertical line should intersect a graph exactly once if it intersects, whoops, spelled that wrong. If it intersects the graph more than once, as what Brandon was saying, it's not a function. Okay, what about this graph I drew here? Would this be a function?
Yes.
Okay. Good, moving on.
Intersecting the graph, like, Caulfield, are you the teacher? No, you're not. You're Caulfield. Anyway, Mr. Caulfield. I feel like a parabola.
So, would a parabola be a function?
I mean, yes.
Well, that one.
Yes.
Absolutely, because
Intersecting them.
vertical lines are intersecting the parabola exactly
Well,
once. So this is a function. You said a parabola is not, sometimes, what would it have to be? On the side?
What about horizontal lines?
So this would be what? Not a function. Because here there are how many outputs? 2 outputs for 1x, or for 1 input, which we know there needs to be exactly 1. Okay? Yes? Yes. Does that kind of make sense? You've seen this before, right? So don't want to spend too much time with older stuff. In addition, you've also well, depending on what class you took to get here, you may have more experience than others, but you should be able to find the domain and range by looking at a graph. So, for instance, if I gave you a graph that looked, I don't know, let's say something like this. This is an open circle. This is a closed circle. And then let's say the rest of the graph looks something like this. Open, sorry. Closed. Yep. Say that louder.
The open circle is over the 1, and then the closed circle is over the 2.
Yes. Closed at 2, open at 1. On this other one, it's open at 2, closed at 4. So looking at the domain, which is what variable? X. What's the smallest x that you see? Okay. Is there any other place where x is 1 besides this point here? Is it open or closed? Good. So 1, and then looks like I'm stopping at 2, but it picks back up right here, right? And it keeps going to what? So then it's 4 with a bracket. There's no union because, well, yes, there could be a union. In fact, there will be for the range. They're not separate sets because x is between 1 and 4. Just because there's two separate pieces does not mean that there's two separate sets for domain and range. In other words, if you take your pen, right? Where's the first place you start?
0.
According to this graph, start at 1. Okay? Do you have to move your pen at all once you get to 2 to get to the next part of the graph? No, because it picks up right here. Does that make sense?
Oh, but if it was at 3?
If it was at 3, very good. Then I'd have to literally pick up my pen, move it over to 3, so that would be a union. Does that make sense? Okay. Yes? Good question. The only way that it would be open at 2 is if this were open and also this one here were open. And then you would have to split it up. But because this is filled in, we do actually hit, or the function actually does have a value at x equals 2. Well, then it wouldn't be a function. Right. Well, the reason that this is open is because if it were closed, then this wouldn't be a function. Because then it would fail the vertical line test right here. So usually functions that are split up like this, which we'll see more of in a few minutes, are going to have like a closed and an open and then a closed, because that's the only way there will be a function still.
Why does it 4 have a bracket though?
Because it's filled in.
Oh, that 4.
Yes. We're looking right. Domain is just x values, right? Let's try the range. What's the lowest y value? Is it open or closed? And now I stop where? At 2. Can I pick up right away, or do I have to stop and start somewhere else? So I'm going to stop this at 2 with a bracket, union, and then I'm going to pick right back up at 3 with a bracket, and stop at 4.
Wait a minute. What? That's why I knew what was going on.
What's that?
Keep pointing with your finger, like what you're talking about. I can't. It says like in the middle of 2 and 3, and I can't.
There's nothing between 2 and 3, which is why we have two separate.
I gave you doing my notes instead of my homework today.
Oh.
And I need them for my homework.
No, let's be nice. Oh, look, some notes. There we go. Yep.
Wait, should I write my name on that?
Yes.
Play with your fingers, Mr. G. I don't know what you're talking
My fingers are too fat. Hold on,
about.
I'll
Play
use.
with anything, I just need to know.
Okay. There you go.
Thank
oh,
you.
No.
Okay. Man, this video is going to be the longest video ever.
Oh, you're recording?
11 minutes in, and we've done
Hello, YouTube.
like one problem.
I'm gonna be a star.
Can you cut me out?
I can't. That's in there forever now. Okay. So, the lowest y value for the whole graph is what? 1.
Okay.
Right? I'm going to roll this up, and I stop.
Oh, okay.
That worked?
2.
Yes.
Close.
Closed. Now, there's no graph between 2 and 3. Right? Between y equals 2 and between y equals 3, there's nothing. That's why we have this
I get it
union.
now. I was
Okay.
going to the X.
Yes, you have to make sure you keep your x's and y's straight. We good? Okay. All right. That's just an example of finding domain and range by looking at a graph. If I give you a graph, so given a graph, you should be able to find values. So, for example, you know what, we'll keep things very easy. Try to catch up a little bit. Let's say that f starts at 1, 3, goes down to 2, 1, and then straight across to 4, 1. This is f. Okay? Now let's say G starts right here on the y-axis where y is 1, goes to 2, 1, down to 3, 0,
Wait, wouldn't that be 2?
or 2, 2, yes, thank you. Down to 3, 0, and then up to 4, 3. Let's say this is G. All right. So what you should be able to do, given any graph, if you have a picture like this, if I ask you to find G of 0, don't shout anything out yet. This means that x is what? So you're going to go to 0 on the x-axis, and you're going to locate where this is, where G is. And then you're going to tell me what the y-coordinate is, because that's what we're looking for. Okay? So again, x is 0, go to 0 on the x-axis, locate where the orange graph is. That's your answer.
Would it be 3?
Where's the orange graph at 0?
3.
At 1. I'm not sure how you're getting 3.
I don't know X and Y.
If x, this is x, these are not always going to be labeled, guys.
I don't.
If x is 0, where's the graph? At y equals 1. So g of 0 is 1. Okay? Let's try another one. Let's say I want to find g of 2.
Is it always X?
1.
It's going to be 2. Because at x equals 2, the orange graph is up at y equals 2.
Wait, but does G represent the X value?
This whole thing represents a y value. This means find the y when x is 0. Find the y when x is 2. Yes?
So they were to tell us if x equals 1, what is the y? Like, would it be g 0?
Yes. Yes. Okay, one more. What's f of 4 going to be?
Wait, don't shout it out.
1.
Good.
I just want to water.
I didn't shout anything out. All right, Jenna. I'm gonna pick on you to do this one. Okay. G of let's say G of 1 minus f of 4. All right. So Jenna, what's G of 1 going to be?
G of 1 will be
2.
3.
Very good.
That's
Now, what's f of 4 going to be?
Wait, how'd you get?
Very good. So your final answer is 2.
Wait, how'd you get 3?
G of 1. Oh, we were looking at the purple one.
I was trying to tell you that I got it wrong, but you wouldn't have going. I said, wait.
So what should it be? We looked at the wrong one.
Yeah.
This is 1.5-ish. Now, did we look at the right one for f of 4? Yes, we did. So what is it, Jenna? Not 2.
Or it's 0.5.
Okay. Thank you. Does that make sense? Looking at the graph, finding the y-coordinates. Okay. Here are the 6 basic graphs that you need to be comfortable with. We're going to go through them quickly because you've already seen them at some point before. And you also have to know the domain and range for all of these graphs. The first one is the absolute value of x. You probably already have a picture in your heads as to what this graph looks like. It's a V, yes. Now, I don't want you to just draw any little V here. Let's actually draw some nice points. So, when I plug in 0, absolute value of 0 is 0. If I plug in 1, what's the absolute value? If I plug in -1, 1, and this is how you get your V. Okay? The domain. If you look at the graph, does this graph go all the way to -infinity?
Yes.
It sure does. You have an arrow pointing that it's going up and left, and it also goes towards positive infinity, so the domain is -infinity to infinity. Good. The range, though, doesn't go all the way down to -infinity. What's the lowest y value?
0.
Good. Now we're starting to see it. We do include 0 because this is not an open circle. It's part of the graph. What about y equals x squared? What shape is that? It's a parabola. And again, you should know some basic points on it, like 0 squared is 0. 1 squared is 1. 2 squared is 4.
Oh.
So you get your parabola that looks something like this. The domain and range are all real numbers for the domain. Good. Range?
Why was it not all real numbers for the first one?
It was.
What do you mean?
It's the same thing. Very good. The only thing that changes is that the shape is a little skinnier, but it's still all real numbers and still 0 to infinity. Yes. You can, but I'm going to stick with interval notation because that's what we need to get really good at. Okay? Any questions on this? Graph number 3. I don't know what my students ate for class or for lunch. It's spread to me. It's infectious. They're laughing, and I don't know what's going on back there. What's that?
No, you don't give him my
I haven't recorded this class except for like that one day.
Yeah, it's exciting.
Yeah, and then it's like this 45-minute video of like three questions.
Nate's gonna have to watch this for homework.
Yeah.
Hi, Nate.
Hey, Nate.
Hi.
Okay, graph number 3. Not an example. Sorry about that. Graph number 3 that we should know is y equals x cubed. If you don't know the shape, it's not that hard to figure it out. 0 cubed is
0.
1 cubed, 2 cubed. It is a squiggly because when you do -1, when you cube it, you get -1, and when you cube -2, you get -8. So it looks something like this. Okay. The domain is what? All real numbers again. The range? All real numbers. Good. Moving on. Fourth one, y equals 1 over x. If you forgot what it looks like, plug in some numbers like, well, 0 I can't do, so that tells me right away that at x equals 0, there's an asymptote. If I plug in 1, what do you get? If I plug in 2, you get what? 0.5. In fact, you probably remember this graph now.
Wait, how do you know when it goes up?
That it goes up? Because if you plug in a half, the reciprocal of 1/2 is 2. If you plug in 1/3, the reciprocal of 1/3 is 3. So the smaller number, as the numbers get smaller, when you plug them in, the graph gets very, very high.
Wait, also, how do you know that it ends where 0.5 is? Like,
It does, and it continues.
how it's like a straight line. Wouldn't it still be going down?
It is still going down. It's hard to draw because it still decreases, right? At 3, it's a third. At 4, it's a quarter. This gets closer and closer to y equals 0, but
Never does.
it never does. Very good. So there's another asymptote at y equals 0. It does have origin symmetry. Very good. When you plug in -1, what do you get for y? 1 divided by -1? -1. When you plug in -2, you get -1/2. It's the exact same shape, but in the third quadrant. Okay. This is the 1 over x graph. You've seen it a few times before. Now we're going to get really comfortable with it. What's the domain here? Well, does this go to -infinity?
Yeah.
And I'm going to keep cruising along, but wait a minute. At x equals 0, what happens?
Nothing.
There's an asymptote there. So we're going to stop it at 0 with a parentheses. And then this is going to pick right back up 0 with an open circle. And this continues to infinity. What's the range going to be?
All real.
It's the same thing. We start at -infinity. We go up. Do we actually hit y equals 0?
No.
Nope, that's the one value I don't hit. So it's the same as the domain. Okay. 2 more basic shapes. Square root of x. In fact, you should already know the domain. What things can we not have inside the square root? Negatives. So the domain is 0 and above. The range, if you're not sure, let's start plugging in some numbers. The square root of 0 is 0. The square root of 1, 1. The square root of 2, let's plug a nice one in. The square root of 4 is 2. So then here's the graph. Looks something like that. So what's the range? Lowest y value is 0, and this does increase, so up to positive infinity. These all look familiar, right? Okay. The last one. It's probably the one that you're least familiar with. Y equals the square root of 1 minus x squared. It actually comes, if you square this, can you guys do this in your heads real quick? Maybe you'll see the shape. If you square both sides, what do you get? Equals 1 minus x squared. So if you square both sides, you get y squared equals 1 minus x squared. If you move the x squared over, you get x squared plus y squared equals 1, right? What shape is this? Very good, it's a circle. The only problem is that these square roots are never going to be negative, right? So this is just the top half of a circle. If we wanted both parts of the circle, you'd see a plus and then a minus in front of this root. Okay? So the circle, the half circle, oops, that's a positive one, sorry. Looks like this. That's the graph for the square root of 1 minus x squared. The domain is from -1 to 1, and the range, what's the lowest y value? 0 to 1. Okay, so these are the 6 basic graphs. Make sure you know them forwards and backwards. Domain and range. Okay?
Wait. I'm trying.
You know, it's always funny looking at the class. See half the class hurrying up and trying to keep up, and then there's always a few that are on their phones, like not taking any notes because they're either caught up or waiting or not paying attention.
What?
Who's that? Andrew?
I didn't say anything.
Yeah, Anthony's on his cell phone
Put
again.
your phone away.
I don't even have a phone.
That's why. That's why I said that. Okay. So, the point of all that. Now we can talk about this real quick. Sorry about that. Piecewise defined functions. A lot of people look at these and are like, oh my gosh, those look so hard. They're really not that hard. Okay, I'm going to do 2 examples. One I'll explain with one method, and the second one I'll explain with a different method. You can pick whatever method you like. Both will get you to the same place, and they're both pretty easy. Okay, a piecewise defined graph is a graph that has kind of like the, let's see, where was that? Kind of like this example from before. It's a graph that's got pieces. Instead of just one smooth, continuous graph, it's got like separate parts of the graph that we're looking at. So, something like this. Maybe part of the graph is 2x plus 1, and the other part of the graph is the parabola x squared. Along with what 2 functions you're graphing, it'll tell you what parts you want to graph specifically. So it'll say, for example, we want this graph whenever x is less than or equal to -1, and then we're going to pick up with this graph if x is greater than -1. Okay, so here's the first method. If you have a pencil, this is a good method for you. Do you know how to graph 2x plus 1?
Yes.
Everybody should say yes. What's the y-intercept?
1.
What's the slope? So I go up 2 over 1, down 2 over 1, and you get a line. So I'm just going to draw that in. And now I'm going to pay attention to where it wants me to look at. This says to only look at this line when x is less than or equal to -1. So I'm going to go to -1, find the graph, which is right here. Which way is less than, left or right? So we want to look this way, meaning I don't want any part of this graph up here.
Wait,
Yeah.
that
Are you sure?
well, she's one of the top.
Now you're why did we erase what we just grabbed?
Because this told me that I only want that graph when x is less than or equal to -1.
Okay.
Isn't that why? Why is -1?
That's a coincidence. What I'm doing is looking at where x is -1, finding the graph.
Oh,
It just happens to be at -1 as well for y.
So it's not on the line.
Right.
Wherever.
It's wherever the graph is. Does that make sense? So because we're at -1, we want lower than, meaning anything to the left I include, anything to the right I erase. Does that make sense?
Yeah.
Okay. X squared, we all know what that looks like. We have 0, 0, 1, 1, -1, 1, 2, 4, and so on and so forth. So you get a parabola that looks kind of, woo, that was not very good. Sorry about that. Okay, so here's the parabola. What does this tell me to do? So again, I'm looking at x is -1. The graph is right here. And I only want to look at the graph that's to the right of that. Does that make sense? Because it's greater than -1. So we erase this part right here.
Isn't this algebra?
Oh, you did? Perfect. And the last thing is, this should be open because I don't have an equal to here. So the final graph would be from here to here. This is part of it. And then from here to here.
Wait, you do have an equal to. X is
Right here it says greater than, and that's it. Where is the equal to? For which graph? For the first one. And there it is filled in.
Oh, I get it.
Does that make sense? Elizabeth?
What is this question like asking?
It's just asking you to graph.
Oh.
Yeah. Now, I could also ask you, what's f of 4? Oh, stop. It's actually really easy. You're going to have like 20 questions like this on the exam. You guys are so whiny. F of 4. You either look at the graph and you're like, well, I don't see the graph. Well, this tells you what to do. Is 4 less than -1 or is it greater?
Greater.
So then all it means is you look at this definition. So the answer would be 16.
What?
Yes.
How would we just find like a random point in the graph? Let's say it was like a point between 1 and 2, but you don't know the exact coordinate calculation.
What do you mean a random point?
Like on the line, on the line. So there's like a point between 1 and 2 or something like that. And we asked them to find it where what's the coordinate of that on the line.
Well, what would the x value be?
I mean, it doesn't give you an x value.
You'd have to be given an x value.
Okay. So, okay, then
Okay. One more example. Now I'll explain it a different method. Let's say f of x equals the absolute value of x if x is between -1 and 1, open at -1, closed at 1. Let's say it's x squared plus 1 if x is between 1 and 2. And let's say it's 1 over x if x is greater than or equal to 2. So here we have three pieces. Okay? Here's the other method. If you don't like graphing the whole thing and erasing parts of it, here's what we do. Start with the first graph. That tells you what x is, right? So I'm going to plug in all the x values. I'm going to plug in -1. What comes after that? 0. And I'm also going to plug in 1 and see what happens. So at negative 1, absolute value of x is 1. If I plug in 0, what's the absolute value of 0? If I plug in 1, absolute value of 1, 1. Now I already made a mistake, I'm sorry. Negative 1 was open, because there's no equal to here at negative 1, just less than. So this should be open. Okay? And we just connect. So there's one part of the graph. So we're done with that one. Now I'm looking at a parabola when x is between 1 and 2. So at 1, is it open or closed? Open. It's just less than, right? So I'm going to plug in 1 into the equation. What's 1 squared plus 1?
2.
So open at 2. And at 2, we're also going to be open, but now I plug it in. What's 2 squared plus 1?
9.
So here we are up at 5. Don't just connect them straight. What shape should this be? It's a parabola, right? So it should get a little steeper as we get closer. And now, for the last piece of the graph, it says to plug in numbers like 2, 3, 4, and so on, right? So if I plug in 2 into my last piece, what's the answer going to be?
1/2.
Good. Open or closed?
Oh, closed.
If I plug in 3, what do I get? 1/3. It just gets smaller and smaller. So it looks something like that. So we got 3 separate pieces here, but not that hard to draw as long as you just draw the correct parts of the graph. Okay?